Yeah.
Hey, let's go. Number one, what did I tell you, easiest thing to do, what everybody usually ends up doing? Taking what?
Putting exponents in the front.
Yeah, but how, you can't move the exponents until you do what?
Log.
Yeah, you have to take the log. When you take the log of both sides, you can move those exponents out front. Right? So, let's move these down. Don't go down too far. All right, so you can put it out front, 3x minus 1, as long as you take the log of 4. And what you do to one side, you gotta do the other, right? So, because I'm taking the log of both sides is the reason I can move those exponents in front of the logs. Okay, that's one of our rules for logarithms. Okay? Now, the next step is to take that log of 4 coli and divide it to move it to the other side. So those would cancel. So you just do log, and remember, when you hit log, it gives you that left parentheses, so 8, then close it off, divided by log of 4. If you don't close it off, it's going to give you a different answer. So that's 1.5. All right, so I got 3x minus 1 on the left, and 1.5 times x plus 1 on the right. Now it's a problem you guys can handle, right? Just distribute the 1.5. Just basic solving equations now, right? Now I've got an x on both sides, so I'm going to take the 1.5x on the right and move it over to the 3x on the left. And I want to take this 1 on the left and move it over to the 1.5 on the right. So those canceled and those canceled. So I get 1.5x on the left. And what is that, 2.5 on the right? And then I divide by 1.5. So 2.5 divided by 1.5 is 1.6 repeating. Anybody get that? Yes? Good. That's 5/3 as a fraction. Okay, we can do all of these types of problems, the exponential ones, by taking the log of both sides. Okay, so we can do that same thing for these others as well. Okay, so this one we would do the exact same thing. All right, so the 2x minus 1 goes in front of the log of 3 equals to the log of 20. And then just divide by log of 3. Always take the one on the left over to the one on the right. It just seems to work out better. So then you get 2x minus 1 equals whatever that is. So log of 20, close it off, divided by log of 3, 2.73, let's just round it to hundreds. So you're going to add 1, which would be 3.73. All right, so plus 1 and divided by 2. 1.86. There it is. That makes sense, those two? Now's the time to ask questions, not just stare at in space and zone out on me. It's not that hard, is it? You guys can do that. All right, now, the other ones are already log problems, okay? So we have to write it as an exponential. What's the base for the exponent? 7. What's the exponent? 3. What's it equal? 5x plus 3, right? So you can put the 7 to the third on the left or on the right. It doesn't matter. Most people like putting the x's on the left. So this number equals 7 to the third power. That's what that's telling us. I just subtract 3 and divide by 5, right? Okay. So 7 cubed is 343. Still skipping on. All right, so subtract 3, that's 740, right? On 340, sorry. And then divide by 5. So 5 goes into 34 6 times, and 8, 68. Yeah, 68. Okay. Now, for 4 and 5, they're not single logs. So what do we got to do? Yeah, single log it. So, coli. What do I have to do to single log it?
You subtract 1?
No. I got to write this as 1 log instead of 2.
Yeah, 1 log.
Yeah, that's what you just told me. So do it. It's subtraction. So what are you supposed to do?
Oh. Divide.
Yeah. You just write 3x plus 1 over 4. Brandon, what's the base? Yeah, the base is 10. How is it 10, people? Because there's not one written. When it's not written, you're supposed to know it's 10. Okay? So what's my equation I can write? 10 squared, right? Equals that. So how do I move the 4? Olivia Wyndham. Very good. So what's 4 times 100? 400. You guys are so smart. And then subtract 1. 399. Divide by 3. 133. Is that our answer up there? Yeah, there it is. Okay? So it was subtraction. To make it a single log, I just divided the first one by the second one. And then there was no number written, so our base was 10 when we rewrite it. Question, does that make sense, those two? Base 7, 7 to the third. Base 10, 10 to the second. This one's a base 4. K. Single log it.
You gotta multiply them.
Yeah, multiply, because it was addition. All right, so we got log base 4 of x minus 1 times 3x minus 1 equals 2. So what's this number equal? Trent? What's on the right side there now? You better know.
You.
Well, there's a 2 now, but when I get rid of this log, it's not 2 anymore. Quit zoning out on me.
Sorry.
Look, this was a 10. So we said 10 squared.
4 squared.
Yeah, this was a 7. We went 7 cubed, right? So whatever the base is, goes to that power. Okay? I know, but is it sinking in? Is it are we understanding it now?
Yeah.
Grace, we understanding it now? Okay. That's the main thing, right? If you struggled yesterday, that's okay, as long as you're trying. Right, Gardner? Okay? Now it's gotta sink in. All right, so what am I gonna have to do to finish this up? Yeah, we have to FOIL. So we got 3x squared minus 1x minus 3x plus 1 equals 16. All right, so it's a quadratic equation now because it has an x squared in it. So to solve quadratic equations, it has to be equal to what? 0. Okay? So we got 3x squared minus 4x minus 15. How do I get minus 15? I subtracted 16, right? From the 1. Okay? Now we have to factor it. Or you can use the quadratic formula, right? You don't like factoring? That's okay. Use quadratic formula. That's a way you've learned, right? You could graph it and look for what? Zeros. What does that mean? Where it crosses the x-axis, right? Okay? That's nothing new for us, is it? We've spent a lot of time solving this. Okay? I want to try to factor it real quick in my head. You don't have to do it this way. You can just use quadratic formula, or like I said, put in calculator, see where it crosses x-axis. I'm gonna go with, maybe it won't factor. 3 and 5, yeah, that works. Minus 3 and a positive 5. So I get negative 5/3 when I set that equal to 0, and I get 3 when I set that equal to 0. Both don't always work, though. All right, so if we go back to the original problem. Okay, if I put a negative 5/3 in here, and I subtract 1, that's a negative 8/3. Can you take the log of a negative number?
No.
No. So can we use negative 5/3? No.
You can.
So just the 3. That one won't work because you can't take the log of a negative. Remember, said our logs, we have to take a positive. All right, so is that helping? All right. So I'll read off the answers. If you want me to go over something, let me know. Number 2 was 5/8, which I don't know what that fraction is. What I said, about a 0.625 maybe, or something like that. Number 3 was -2, and number 4 was also -2. Number 5 was 1.661. Number 6 came out to be 0. We'll go over that one. Number 7 is 0.503. So let's look at 6. You guys let fractions freak you out or something, I don't know. Okay? So 1/4 to the 2x and 1/2 to the x. Okay? So if I go 2x log of 1/4, just I took the log of both sides, moved the exponents out front, and this would be x log of 1/2. You with me? Just taking the log of both sides, and again, we're moving that exponent in front of our log, our power property of logarithm. Okay? Divide by log of 1/4 to get it to the other side of the equation. So all I got on the left then is 2x, because those will cancel. So log 1/2, remember to close it off, divided by log 1/4. Close it off. That's 0.5. All right. So my book says 0, but that doesn't come out to 0, does it? Doesn't that come out to 4? What's 1/2 divided by 2? Isn't that 4? Oh, it's 0.25. What am I thinking? Or 1/4. Why did my book say 0? My book was wrong. I don't think I'm wrong this time. Did I write? Right? 2x? Did I do something wrong?
Where is the X down?
Oh, that x on the other side. Duh. I did something wrong. It's 0.5x, right? Sorry. All right. I missed that. All right, so this was 2x, and this was 0.25x, right? No, I already did the 0.25, didn't I? So it's x and 0.25. Sorry. Let me go back to here. I got to get these together on the same side. So it is 0. How do I move this over to this side? Subtract it. Oops, get back my pen. What's left on the right when I subtract 0.5x? Nothing, right? 0. And then 2 minus 1/2 is 1.5, right? What's 0 divided by anything? 0. So 0 was the right answer. I forgot about that x being there. Rookie mistake, yeah. Okay? Any of the others up to 7 you want to look at? Okay, number 8. Let's do that one. It gives us a formula. It says the population of a small coastal resort town, currently 3,400 people, grows at a rate of 3% per year. This growth can be expressed by this equation. That's the equation we had on that last quiz. You know, the beginning amount, population, beginning amount, growth is 1 plus 0.3% is 0.03. And then it said to the T, P is the population after T years. Find the number of years it will take for the population to exceed 10,000. Okay? So we could solve that by putting what on this side? What do we want this to be? Exceed, what's that mean? More than 10,000. So let's just put 10,001. Is that more than 10,000? Again, this is practice solving. Okay? first thing I would do is move the 3,400 over. How do I move it over? Divide, right? So smart when you want to be. When you're not zoned out. 1 point plus 0.03 is just what? 1.03, right? So let's just do that. And what's that? 10,001. All right, yeah, 10,001 divided by 3,400 is 2.941. All right, so what do I have to do to solve for X, for T? How do we do those now? We just learned. Take the log of both sides, right? So this would be log of 2.941 equals T times the log of 1.03, right? I can move that T out front now, right? Now what do I do to get T by itself? Divide by what? Log of 1.03, right? All right, so I got that 2.94 in there, so I'm just gonna go log of the answer, second answer, close it up, divided by log 1.03. 36 and a half, so how many years? Yeah, 37. Okay. You should be able to solve that now, just like we did, right there. Oops. T equals 36.5. All right, that was number 8. Number 9 was 1/8. Is that 0.125? 10 was 106.5. 11 was 108. 12 was 4.33. 13 was 9/13. I don't have the decimal for that. 14 was 4, 15 was 2, and 16 was 1/5, which is 0.2. All right. So let's look at 9. Car, are you paying attention?
Yep.
Doesn't sound like it. This is really easy. Why is this really easy?
The same base.
They have the same base. So if log base 2 of this amount equals log base 2 of that amount, what must be true about those two amounts? They're equal, right? You just write 7x plus 1 equals 2 minus x. Okay? So if you have a log on both sides, and it's the same base, which it will be, in order for log base 2 of this to be equal to log base 2 of that, these two things have to be the same, right? That's just common sense, isn't it? Okay? So that's a really easy type when they got a log on both sides. A single log. Now, if you have multiple logs on the side, you got to make it into a single log, right? Addition, you'll make multiplication. Subtraction, you'll make division. Okay? So we're going to add x. Subtract 1, divide by 8. There's your 1/8. Okay? So that's an easy type of problem. So don't let those mess with you. Now, 16 is a little tougher. Okay? Right, so focus, pay attention as we do this. This is log of x plus 3/10. plus log of x plus 1. Okay? So I would take the 1 over here. How do I move it over? Subtract it, right? And what will we do with those two? Multiply, make them a single log. Right, so this would be log of x plus 3/10 times x. Okay. So Andrew, since you've been really paying good attention, what's the exponential problem now? -1 to the 10th or? No, flip it. Right, 10's here, right? To that power. Okay, because there's no number written, so it's base 10, right? Equals x squared plus 3/10 x. I just distributed, okay? So what is 10 to the -1? Come on, you should be able to tell me that. Yeah, 1/10, right? What's the negative exponent do to our base? Reciprocal. So what's reciprocal of 10? 1/10. You with me?
Yes.
You guys know that, right? But sometimes you forget. But that should be sinking in now with the negatives. Okay? So what am I going to do with that 1/10 now? Subtract it, because we have to set it equal to what?
0.
0, right? Okay? So it's kind of a pain problem, because it's got fractions, right? So I would probably use the quadratic formula. All right? So negative b is negative 0.3, right? Can't I just use the decimal? Plus or minus the square root of 0.3 squared minus 4 times 1 times negative 0.1. C over 2 times A, right? All right, so what's 0.3 squared? Minus 4 times a negative 0.1. What's the square root of that? .7, right? All right. Negative 0.3 minus a negative 0.7 is a negative 1 divided by 2 is negative 1/2. Negative 0.3 plus 0.7 is a 0.4 divided by 2 is 0.2, which is 1/5. Okay, so that's a fraction. The decimal will be negative 0.5, 0.2. Now, can I take the log of a negative? No. So my only answer is the 1/5. That's what the book said, 1/5, 0.2. That was a tough one. You won't get one that tough on your quiz. Okay? But it's something you guys should be able to do. All right, so nothing new today. We just need to practice more of these, okay? Do you have any of the homework ones that I didn't go over that you'd like me to do? One that you weren't sure, you wanted to just a quick go over? Okay, so for today, I'd like you to do the same page, 526, numbers 22 to 32 even. So not as many.